Okay, so today we're going to start the second part of this course. So this course is eventually going to get you to the cloud. And the first part was all about the networking, all the plumbing that goes on to get you the cloud. And a lot of that low-level stuff you still actually need when you're deploying stuff on the cloud. But to get you to more cloud applications, the first thing that we need to do is develop an application that we want to deploy on the cloud. And to do that, we need to go build an application, and that's where the web development part of this is. I am not going to assume you know a lot about the web and how the stuff is developed, so some of this stuff might be a little bit basic. But still, I'm gonna go through it because I think it might be helpful as a starting point that we all get to a certain level. So I am going today to talk about web development at like a 10,000-foot level. I'm going to talk about the individual components that your web application might have. So you'll select a programming language, maybe you'll select a framework, and then that framework might have different template systems. So what are all of these things and how do they work is basically what we're going to talk about today. And then I'm going to finish off with rendering approaches, sort of where our modern frameworks are leading us to architecturally. Okay, so actually, I'm going to have to pause here for a second. So we're going to go through some of the characteristics that your programming language will provide you or not provide you as it may turn out. And if you are starting a new project, a new web application, these are the things that you should think about before you say, hey, I want to use that programming language, or I want to use this. It's often the case that you'll get to a company and you're going to be using whatever someone else chose. But in the rare instance that you get to start a project of your own, then maybe you can go back and revisit the kinds of things that you might look for when you're building your project. The first thing that you might think about is whether or not your programming language is compiled or interpreted. So compiled means that you take your program and you bring it all the way down to machine code. And when you do this, you don't need a runtime environment to execute your machine code. It's all there. And it's typically much faster. And if you are developing a web application that runs, for example, on an embedded device, then this might be what you would want to choose, because an embedded device might not have the capacity to run a full-on environment. You could also compile it down to bytecode. So bytecode it's not all the way down to machine code, but it goes to a simplified sort of a virtual machine code, and then you would need a virtual machine to run the bytecode. So that is one approach. The problem with compiled languages is that it's typically going to give you a longer development cycle for turning around like applications and changes to applications, because you have to recompile the whole thing. The other issue that has come into play is the inability to patch anything quickly. Like any bugs that you have in a compiled web application, you have to actually go, if you're an operations person and you realize there's a security vulnerability, you have to actually go back to the dev team and have the dev team do something about it. Whereas what you would like to do as an operations team is just to update the vulnerable package, for example. But in this case, if you have a compiled application, you actually have to go and recompile the whole thing. And so you need both dev and ops to fix any security issues versus just ops. And this came into play with the Apache struts bug, which basically owned Equifax. Equifax was using Java with struts, and the vulnerability was released, and within 2 days, it had been exploited on Equifax. And that just didn't give them enough time to go back and actually fix the thing. So they ended up getting owned. So your other option is interpreted language, so a scripting language. If you're going to do this, you require that your interpreter and all of the specific packages and the specific versions that you're using, are there sitting on the machine that you're running this application on. So for example, Python, JavaScript, and PHP, you would pre-install all of the code you would need to run that particular script. They're typically much slower, but a lot of these scripting languages I've been working on their just-in-time compilation to get the thing down towards machine code so that it runs faster. And so things like PyPy and then JavaScript's V8 engine are trying to get the performance of these interpreted languages down to something closer to compiled code. The other thing in your language will be the typing system. So you could have either static typing or dynamic typing. With static typing, the types are checked at compile time. You declare the type of every single piece of data in your program that your program uses, and then the compiler will make sure that the way you're using those variables are faithful to the type that you declared those variables to be. And in this case, the type errors are caught by the compiler before you deploy it. Right? Like if you're playing fast and loose with your variables, the compiler is going to be like, oh, you probably made a mistake here. I'm not going to let you run. So it's the idea that you debug before you deploy your application, which is actually a good thing for most people. And this is really good if you have an application that's mission and business critical, which is probably most applications out there would want this kind of approach. This is versus dynamic types, so where the types are checked at runtime. So here's a piece of code. I think this is JavaScript. I have a variable. I set it to 3, and then variable gets the return value of foo, called with a parameter of 0. Can you reason about what the type of that variable is? Well, no. In a dynamic typing system, you could write something that looks like this. Function foo, if it's 3, I'll return a string, a character 0, and if it's not, I can return the integer. So this makes it much harder to reason about what the code is actually doing, because this is a runtime thing that you have to debug if you're playing fast and loose with types in your program. So a lot of people don't like that, right? Like this makes things really hard to validate, actually. Type errors are caught at runtime via crashes. And this is a problem for a lot of people. So this is why Python and JavaScript they're seeking modifications to make this less of an issue, which we'll talk about. Okay. Or it could be even worse than just errors that are thrown at runtime. You could have some scripting languages, PHP being one of them. You basically will not catch any errors, type errors. Instead, you will coerce the data type to your best guess of what you thought the programmer meant. So if the programmer gave you a string and PHP is like, you know, a string doesn't quite work here in this way you've used it, I'm going to turn it into an integer, that's what it'll do. So it'll give you nonsense results in order to continue. So that's PHP for you, which is why you have to be very careful if you're programming PHP. You have to know what you're doing. And then the other thing is overhead. You're going to do this type check for every operation to make sure that the result will give you something that you can reason about. So this is done at runtime, which makes that's part of the overhead for a dynamically typed system, to be checking this all the time. Okay, so the model for dynamic typed languages is to deploy and then debug. So this is good for rapid prototyping. So if you want to throw up a web app very quickly, this is what you would do, which is what we want to do, so this is what we're going to do. But it's not necessarily the way people want it to be done. Okay, another characteristic is a strongly typed system versus a weakly typed system. So in a strongly typed system, you require explicit type conversion in order to mix and match types. So for example, what will this give? So for anyone who knows Python, what will this give you in Python? Anyone? PHP would definitely concatenate. This is a trick question because Python would actually do the right thing and say, no, you can't do this. So Python, it's dynamically typed, but it's strongly typed. You can't do this without Python complaining. Maybe earlier versions of Python did the coercion, but Python as it is now will not coerce. So that actually is a good thing. So this is what you want, I think. Is what you want, I should say, versus a weakly type system. So a weakly type system will implicitly convert your type based on how you're using it and then cast it to something else. So it automatically changes a value from one type to another without the explicit signal from the programmer. Okay? So PHP is one of those. So what do you think this will give you? This is my PHP script. I just print the string 5 plus 8. Yes, this will give you 13. It'll add the 2. It'll coerce the string 5 into a integer 5, and then add the 2, and it'll give you the number 13. So and then you have to know this, right? Like if you're using PHP, you have to know this. Like an error where you have a type mismatch error won't signify. It won't signal you that something bad is happening. It will just do this and move on. So this hopefully isn't the first time you've seen coercion. So if you've taken 201 from me, I don't know if any of you have, I haven't taught it in a long time, but 201, what is, hopefully this doesn't give you any nightmares of 201. What does this give you? What does this program output? I have a character, which is a single byte. It's hex 80. I say printf, %x, this character. Like if I'm a beginner programmer and I read this program, it'd be like, yeah, I should get hex 80 back, right? That's what the thing says. But no, you get this. And so you get all F's and an 80, and then if you were a beginner programmer and you saw this, I'm like, programming's not for me, right? That makes no sense to me. And that's almost like one step beyond hello world, and already I can't understand what the thing is doing. And that's not the fault of the person learning the program. This is the fault of C. C is doing this implicit conversion of a byte, in this case a signed character, into a signed integer of 4 bytes long, which is what's happening here. So again, you have to have explicit knowledge of these coercion rules in order for you to reason about what's going on in your program, which is a pain. Worse, and I put this in here because this is worse because it also depends on the actual processor you're running on. On an ARM, this would print hex 80 happily. It's only on x86 that this casting rule exists. So the compiler says on it, it's a rule that's enforced differently. It's an optional rule that's enforced differently on different architectures. Okay, so unfortunately JavaScript, which is the language that almost everyone is using for both back-end and definitely front-end stuff, does coercion. And so this is a nice tour over the JavaScript coercion. What is the string 5 minus the string 2 going to give you in JavaScript? If any of you are taking the full stack course? Anyone? Okay, what would this give you? And you should get these wrong because these aren't obvious. I mean, they look obvious, but they're not, which is why they're up here on the slide. This gives you actually the integer 3, okay? And then the other one, this 5 plus 2. So it's like, maybe that should give you 7, but this gives you the string 52. And then 5 minus the string 2, now you're confused. Maybe this will give you 3, and it does. And then 5 plus the string 2, this will do a 52. So if you're shaking your head, yeah, me too. I'm just typing these into the interpreter. Like, I don't know ahead of time, because you have to know the coercion rules in order to really figure this one out. And so I'm not going to memorize JavaScript's coercion rules. This is the reason why you would want stronger types in your JavaScript, which is going to motivate another language later on. So here's another example, along with some of the arcane rules of JavaScript coercion. So 0 equals to string 0. Is that true or false? Turns out this is true. And the rule is if x is a number and y is a string, then what this will do is return x is equal to number that string. So the coercion is explicitly applied to the string to give you an integer. And then this one, 0 is equal to an empty array is what this notation is. And this is also true. And the rule is if x is a string or a number and y is an object, then return x is equal to 2 primitive y, where 2 primitive coerces to a string, number, or Boolean. That's the rule. The empty array in the case of JavaScript is an object. Objects are first coerced into a string. And so the empty array as an object, when coerced to a string, will give you an empty string, and then an empty string coerced to a number will give you a 0. And then 0 is equal to 0. And then you have something like this. Well then, if the top two, 0 is equal to string 0 and 0 is equal to the empty array is true, well then is the string 0 equal to the empty array? And this is of course false because it's JavaScript. And this leads to hilarious memes actually, which is what that thing is. So if there's a link to this somewhere, you can go look that up. And it leads to hilarious talks about JavaScript, which I would highly recommend if you haven't seen this before. I know Stephen Libby plays this in his programming language class, so I'll skip it, but it's pretty funny. Okay, so another aspect of your programming language is type inferencing. Some people like this, some people don't. It's the automatic detection of types so that the programmer doesn't have to declare it. You'll find with statically typed languages, they're extremely verbose. It's a pain in the neck for a programmer, well, for some programmers, to have to annotate the type of everything everywhere in the program. So type inferencing allows you to drop some of those labels. It allows the compiler to just say, well, it was returned as this type before. I'm just going to assume that that's the type later on so that you don't have to like relabel the type all over the place. So when I say let x is equal to 3, I don't have to say what the type of x is. X is going to be a number. It's inferred to be a number just because I have assigned it using this literal. And this is going to reduce the language verbosity, but then this is perhaps at a cost, because whenever you're not explicit with the typing, when someone is reading your code trying to reason about what the variables are, that is lost. So understandability might go down, and that might increase bugs potentially. So Kotlin is sort of a dialect of Java that does this to great effect. People like that, and it was so successful that Java eventually adopted it for itself in order to compete, because everybody was enjoying the type inferencing, I should say. Okay, another aspect of the programming language are the kinds of paradigms that the language can support. So there are two main classes of programming models. There's the imperative programming, which is what you would get with C and C++. And then there's the declarative one, which are more like functional programming languages. So if you've taken 320, that's basically the kinds of style for that. So these are more based on functions and operations on operations versus the data, focusing on the data itself. So functional programming, it turns out, helps you manage complexity while reducing errors. And this is a model that's being adopted more and more in complex web development and in complex cloud deployment management. So you would typically, if you are dealing with some complexity and you feel like functional languages can help you, then you would look for this kind of support in your language. And it has a similar goal to object-oriented programming. And so I like this quote, whereas object-oriented programming is trying to make the code understandable by encapsulating all of the state and the moving parts in that state. Functional programming is trying to make it understandable by getting rid of all the moving parts. So you can reason about parts as being invariant and static, rather than being manipulated out from under you and giving you strange results back. So this is part of what the functional programming paradigm would give you. Computation as basically a composition of mathematical functions is one of the things that it will do. Stateless operation, so you only want your function to depend on the parameters that have been given to it. No side effects and immutable data. So this is part of being able to reason about what's going on in your code better. You want to avoid changing the state, or if you do have to change state, you want to minimize where all that state change is happening. And this will come into play with modern web frameworks, which are trying to localize where the changes are happening in a DOM, in a web page. And this is more towards a functional model of execution. And so, for example, rather than modifying a list in place, the idea would be to create a new copy of that list and then change that instead, would be the idea. First-class functions, where functions can be treated as objects and passed all over the place. And then lazy evaluation, where you only compute things on demand. And this will come into play when we talk about data processing pipelines in the cloud. Okay, so a lot of these things are being applied heavily in web development and data science, which is, if you are learning functional languages or are interested in functional programming, you'll see a lot of reuse. So I would recommend, was it 457 or 557 for a graduate student. Another important issue is asynchronous support. So whether or not your language naturally supports event-driven programming and non-blocking operations. This is especially prevalent in the web because initially, for web browsers, any program that was executing on the browser was given a single thread. Because you don't want to block the UI for JavaScript code that you might run, that you download from the web. So basically, every single operation that JavaScript runs has to be non-blocking. Like you can't sit there and wait for example, input to come from a device in JavaScript. And any blocking calls need to automatically yield to other parts of your code. So whether or not a language supports this is crucial if you rely on this style of operation. An example of asynchronous support is the idea of callbacks. So callbacks are functions that you register so that when you execute a particular operation, it will call this function when that operation completes. And that operation might block. So you issue an operation, it blocks. The program that you're running will just continue to the next instruction. And then as soon as that operation finishes, you'll invoke the callback associated with that operation. So here's an example where it's synchronous file writing. So this is typically what you would get in a C program running on an operating system. You say file object is open file, and then this blocks until the operating system finishes the open. And then right after the open is returned and you get a file object, then you can do the write. So this is what you don't want. You don't want the thing to block on an open. What you would like to have happen, and this is the asynchronous approach, is that when you open the file object, you open it with a callback write to file. So in this case, when this thing executes, it'll immediately return. And then as soon as this thing is done opening, it will invoke this write to file code, which will actually do the write. So this is the pattern that you'll see in the JavaScript frameworks and in JavaScript if you take the full stack course. You see callbacks everywhere. Okay. Other common mechanisms to support asynchronous operation, closures and promises, which are, I am going to talk about this because almost all of the modern frameworks are trying to support disconnected operations, which is what closures and promises help you with. And this is really key for implementing your front-end UIs. Another aspect of your language is concurrency support. So some of these, so especially for back-end web development and cloud service development, you want to be able to leverage, if you have a 96-core CPU, you want to be leveraging every single core to process whatever API you might be implementing. So you want your language to support multi-core processors, to be able to support parallel execution, and then to have a memory consistency model that doesn't bog you down, that allows you to use the parallelism on your server. Another aspect is ease of development. You want to be able to program easily, test easily. You want to be able to have a rich library and package management support so that you don't have to write all of the code from scratch. So if you have a community of developers, that's typically better. And then ease of deployment. You want to be able to take your development code and be able to spin it out into production very quickly without too many issues in the deployment. Okay, so that is the general features in a programming language that might matter to you. I am now going to talk about the specific programming languages that you'll typically see for web development. The first thing is Java and C#. So this is prevalent in most of the e-commerce and banking sites. First of all, is one of the earliest languages. They were the earliest languages to support web-based frameworks, basically. So this was because JavaScript and PHP and Python, they didn't have any support for this I think it was like the mid-90s to late 90s. So a lot of applications got written in Java and then C#. With these languages, you compile down to bytecode, and then it's interpreted by either the .NET runtime or the Java virtual machine in the case of Java. And then they do have just-in-time compilation of the bytecode for both of these if you choose to do so. They are strongly and statically typed. And there's a reason, because these are typically mission-critical applications for e-commerce and banks. It uses managed memory that's garbage collected. It has asynchronous support. In Java, it's this event interface, and in C#, it's this async await interface that JavaScript liked so much that they basically took. So the async await stuff comes from C#. It's got a huge developer base, mature Clash support, and then it's starting to add conciseness, as we talked about earlier with the inferencing. Okay, but with deployment, as I mentioned earlier, you have to recompile all your apps whenever security issues occur. So if Microsoft or Oracle delivers a patch to a certain class that has a security vulnerability, you have to go, because you're updating the Java libraries underneath your app, you have to go and recompile your app with the new libraries in order for it to work. So it won't be an in-place update of a package. You also have vendor lock-in. So people were really upset with Oracle when they switched from Java 7 to 8 because it was really buggy. They re-implemented everything, and the new thing was pushed out the door without much QA. And so you had all of these, you could see the number of cert advisories on Java just went through the roof in like 2015 or 16 when they did this. So you rely on the vendor. So if it's a vendor-controlled ecosystem, like sort of Java and C# was, then that's your supply chain. But at least you have someone to call when your supply chain is messed up, which is what we'll get to later. And then the next one is JavaScript. So this is basically when Brendan Eich developed this. He developed this in 10 days, which is why it has some of the issues that it does. This is scheme in a browser. I mean, this is a heroic effort, but like still, like who's gonna develop something in 10 days that's gonna last? Well, it's gonna last forever, but like that is gonna be secure forever. It's not gonna happen. So it's interpreted, but a lot of people have been working on the JIT for JavaScript just because it's used so prevalently. So Google, with their V8 engine, they really took the screws to JavaScript to make this thing a higher performing language. It's dynamically typed and it's weakly typed. So the type checking is at runtime, and then there's type coercion everywhere. It's got garbage collected memory. It is asynchronous from the get-go. It does asynchronous operation better than almost any language that's out there. Just out of necessity. So it began with single-threaded operation, so it had to do event-based stuff almost immediately. And so anytime an asynchronous sort of abstraction comes up, like a callback, a promise, or a closure, you can bet that JavaScript is going to implement whatever it is, and they do. In terms of development, there's 400,000 packages on the Node packet repository. And then this is really nice because both your front end and your back end can share the same language. So back end web apps can run Node, and then you're shipping JavaScript on the front end as well. So Node.js is a JavaScript server. It's JavaScript running on the server is what Node.js is. This is typically used for smaller web applications requiring quick development. And rapid results, and that's my opinion. That's typically where developers love it because they can rapidly prototype something and ship it, and it just works. Okay. So I'm going to revisit type coercion in JavaScript because it forces you to do some crazier things. So because of this coercion, it leads to this loose equality operator. So the equality operator, the double equals, that checks equality after all the coercion rules are applied. And because nobody can remember the coercion rules, it is suggested that you never use the double equals. And in fact, one of the former full stack instructors, he would mark you down every time he saw double equals in your code. He was like, you should never use this, and I'm going to give you, dock your grade every time. Because you should be doing, because this is one of the problems. You can have these three objects that are clearly three different things, but when you check their equality, they're all true. They're all equal to each other. So this is the kind of equality that double equals gives you. And so how do you really check for equality? Well, in JavaScript, the triple equals is equality without coercion, which is typically what you would want as a developer. So you should probably it's a very rare case that would need the double equals. I know of no case that would legitimately need that. Or you would use object.is. Did you? Can you use it for string comparison? You could. Why, like, versus a triple equals, which would do something different, or?
Triple equals, wouldn't that give like the numerical value of the string? If you wanted to know, like, if like the character.
I believe if you're doing, it does the comparison based on the types that you're comparing. Yeah. So yeah, it won't do the coercion. That's the whole point of the triple equals. No coercion is happening there. So here's a table of the differences between, you can barely read this, but here's the double equals in all the cases that double equals is true with the two operations. And here are the cases where the triple equals will give you true and then not true. And these are the things that you would need to understand if you want to, if you're working in JavaScript and are using the equals. Okay, so that's a cheat sheet that you can use. There's another nefarious issue, and I put this in the JavaScript section, but this applies to any language that's got a package repository that you are actively using. There are issues with securing the supply chain on all of the packages that you're using. How do you know if a rogue developer isn't going to insert something that hijacks your web application? And so this has happened in the past. One developer can make one change that breaks a whole bunch of applications. And this is where your vulnerable supply chain is really coming home to roost. Like, you have to make sure that that stuff doesn't change or not have your business rely upon it. So sites that are using packages that are abandoned is prevalent, where those packages aren't being updated whenever there are security issues. So if you have a package that's got a whole bunch of advisories that are flagged on it and it's not being updated, that's a problem for your app, because then anyone can compromise your app through that module. And so on one of the things that GitHub has been doing is it's been going through all the repositories that people have, looking at all the modules that they use in their project. And if it's relying on a module that's got a known vulnerability, it will flag you. It'll give you a big red flag that says, you're depending on a module that's insecure. You should do something about it. That's just a recent thing that they've added in the last year. Another issue is any of these packages can be taken over by a malicious developer. So if you're a fatigued developer on your own package and someone wants to take over the management of your package, then who is vetting who controls that package repository? That's another issue. So here's one where this was a thought experiment. It's like, if I wanted to own a whole bunch of websites, what I would do is I would create a module and put it in NPM that's a super useful widget, and I would get a whole bunch of people and a whole bunch of sites to use it, and then I would just go and steal all the credit card numbers underneath with one change. Okay, so another language that is really becoming popular is TypeScript. So we've got all these issues with JavaScript, and that's why I'm using TypeScript here. This weak and dynamic typing is leading to all sorts of software engineering problems. As soon as you have a JavaScript, a Node.js application that gets to a large enough code base, you're going to have a hard time reasoning about what's going on in that code base. And so the idea of TypeScript was to try and put a strongly typed type system on top of JavaScript. So it's a superset. And then what you would do is you would compile that down into regular JavaScript so that it could run everywhere, so that Node.js could run it. So that's what TypeScript is. Statically typed objects, strongly typed objects, so you have to do explicit casting in TypeScript. And this is checked at compile time when TypeScript is compiled into JavaScript. Okay, and this is why a lot of these production companies are making sure that they start their projects with TypeScript. There's another approach that's popular, and that's PureScript, which is, again, strongly typed, statically typed supersets of JavaScript. Another programming language that's popular is Go. The idea of Go is that, and Go came from the other direction. It started from C and C++, and it wanted to make a language that was sort of native for the web. So it took the best parts of C and C++, which is a low-level systems programming, and compiled performance. They wanted this thing to be bare metal, because when you are servicing web requests, it's got to be fast. But they also want the best of Java, Python, Ruby, and JavaScript. All the cool kids are programming that. And you want to be able to offer some of the same features that all these developers are flocking to these scripting languages for, well, mostly scripting languages on the right. So you want garbage collected memory. So if you've programmed in C and C++ and you've taken Carla's courses and you're allocating memory and you're dealing with pointers, you want none of that, right? Like that's like a lot of cognitive load on a programmer to keep track of the memory that you allocate and making sure you free it. And so managed garbage collected memory is something that you really want as a programmer. And then you also want rich package and module support, just like these, like Python and JavaScript particularly have. You also want the best of JavaScript. So first-class support for asynchrony and concurrency, and then first-class functions are another thing you would like. So that's sort of what Go was designed to do. So it was designed also for simplicity and readability. One of the problems with code and programming languages is that when I write, for example, a Python program, it'll look completely different than when other people write Python programs. And I run a teacher camp where there's people learning Python and then people who have programmed a lot of Python before. And you can see the advanced language constructs that an advanced programmer uses versus a beginner program would make it so that it's the same language, completely unreadable. So Go decided there was only one canonical way. We're not going to do object-oriented. We're not going to do certain styles of imperative programming. We're going to do one way. There'll be one canonical way, and it'll be designed for readability. There hasn't really been a programming language that has been designed for readability. And so they thought that this was key because inevitably it's multi-developer out there. Like you need to be able to share code and understand other people's code immediately. And so this was one of the key designs of Go. The features are fixed. So it's not like Python and Java. They're adding different operators and features into the language. And then feature creep makes it so that the language is really confusing. Like there are some things that are being added to Python. And I'm like, oh my God, this is going to make my Python code completely unreadable to beginners. Like the colon equals. It's like, oh, wow. Nice new operator, but it completely changes the way you would program Python. Go says no to all of that. So they're trying to fix the features. They're trying to make the language spec really simple, so only 25 keywords and not growing very, very quickly. And that's the fundamental design for Go. Some features, it's strongly and statically typed, like Java is. So this completely gets rid of the runtime errors and the type coercion problems. They wanted to support rich built-in types. So it's not like C and C++ where you basically have to roll your own for everything. In this case, there are maps, there are slices, there's first-class functions. You have functions that can return multiple values rather than the single return value that C would have. You have iterators in Go. So it's really giving you a full-featured language that eventually will compile down to bare metal. It does type inferencing. It gives you memory safety via garbage collection. And so one of the courses that we offer here is Rust. Rust will give you memory safety via compiler checks and developer knowledge. So if you, a lot of people don't like garbage collected memory because this is overhead. Like the garbage collector has to wake up and run periodically. And so if you don't like a garbage collected language, then you might want to try Rust. And then it's got rich built-in module support for the programmer. And then this goes along with readability. It has a standardized code formatter called Go format. So this is basically like a built-in lint. So everybody's code looks the same. So there's no more spaces versus tabs like the Python world used to have. There are no style guides needed, right? Like you don't need to define a Go style guide because everything is reflowed using this formatter. So the readability issues are built in. In terms of asynchrony and concurrency, it was built with those primitives in mind. So it's got the ability to do non-blocking concurrent operation with these things called Go routines. And each of these Go routines, you spin them off, and they spawn off a new thread in the operating system. So that can be run on a core, on a CPU core. And so you get this parallel execution without something like a global interpreter lock. So a lot of the interpreted languages, this refers to Python. Python cannot do multi-threading. It can't take advantage of multiple CPUs because there's this global lock on it. So it's typically a one virtual CPU execution of your interpreter. And Go will support this with very simple syntax. So here's an example of how you would, well, maybe there's the example. The example is here. So I have some heavy computation that I want to run in parallel. And I create this channel that says the result of this is going to be sent on this channel, and it's going to be a 32-bit result. And then what I can do is I can, in my program, to kick this computation off, I can say, I want to create this channel, CH, and then I'm going to say go heavy computation with that channel. And then when I let that, and this is non-blocking, I can go and do something else. And then when I need the result, I can then use it somewhere else in the code, and then this will block if it's not ready. If you are, you can check before you do this to make sure that it won't block. And so this allows you to spin off a parallel computation with very little syntax. So it's like 3 letters, or two letters, and then the code that you want to call to spin off a new thread. If you did this in C, you would have to like do an include the thread package. You have to do a pthread create. You would have to do all of these other things. So this is what they mean when they're talking about making the concurrency streamlined in Go. Okay, so static efficient compilation to bare metal. So the performance is then close to C and C++. It's within like 10 or 20%. Most benchmarks have Go being very close to compiled C. It's got this built-in make. So if you have a large C project, you usually have a make file associated with it, so that if you change one C file, you don't have to recompile the whole thing. So Go just does that automatically. You don't need a separate building tool for Go. It's easy to deploy. So when you build a Go application, you get a single binary, and that binary has everything in it. And all you have to do to get that program to run on some other server is copy the binary over. That is way different than what you're going to get with Python and JavaScript, where you're having to copy packages over, you're going to have to install, you're going to have to do pip, you're going to have to do all this stuff to actually get your environment over to the machine that you want to run on. So this is important for dev versus ops. I can just ship you a binary rather than having to ship you all of my code and all of my environment in order for you to run what I created over here. Okay? And this actually, so one of the reasons for Docker containers was because it was such a headache to get someone else's environment over into production. So the reason why we have containers is because of this deployment issue. Well, the way Go works obviates the need for a container. I have everything in that binary, and that's all I need. Okay, so this was just trivia. This was used to build the world's smallest Docker container. This is a floppy disk for those who have never seen one before. It's a 1.44 megabyte disk that you would insert into a drive. The world's smallest Docker container can fit in that. So you can watch that YouTube if you are interested in that. And Go is being used to build all of the large internet scale applications. So this is used to implement Docker, to implement Kubernetes, which we'll be using later on in this course. It's used to implement a lot of the high-performance web APIs. So later on, when we start using Google APIs, on the back end, that thing that's processing all those requests that you're sending it is inevitably going to be something written in Go and compiled down to bare metal to process your requests. And so the reason why is because a lot of these modern frameworks, they were never meant to host large-scale web APIs. So JavaScript, Node.js wasn't meant for that, Rails wasn't meant for that, Django wasn't meant for that. These things were not meant for high-performance servers, which is where Go is meant for. And so a lot of companies are switching over, Google in particular. Microsoft is all in on Go. They hired a bunch of the Go developers, and a lot of their stuff is being written in Go as well. Okay, so there are some issues in Go that you have to be aware of. Because it's statically typed, it makes handling arbitrary JSON. So JSON is basically the de facto data format that we've been sending back and forth between web client and web browser. It's really easy in a dynamically typed language to be able to parse one of those things and generate a new object. But if you are a statically typed language, that's really hard to do, right? Because you don't know the format, you don't know the types of everything in that object a priori, and then you're having to construct that dynamically. So that's one issue with Go. Go also doesn't support exceptions, like in Python you would use a try and a catch. And if you want to do something that does some kind of error handling, then you would use the multi-return to do that. Because Go compiles down to a single binary, if you have a bug in any of the parts that you use to generate that binary, you have to recompile. Just like Java had to be recompiled to patch any security bugs in packages. So this is a drawback as well. Okay, and this leads us to Python. So Python is what we're going to do in this class. This is an interpreted language as well, but can be compiled to bytecode. And you'll see at runtime that the interpreter will dynamically produce compiled Python. This is why in your git ignore file, this got added, because I don't want to see your compiled Python when I do a git clone. And Leslie doesn't want to see it either, so that's basically what's happening. It's dynamically typed, but it's strongly typed. And then it uses managed memory. It has some asynchronous support, but asynchronous operation was never native to Python. So you have this async module in 3.6, but it's not really part of the language per se. You have to import that module. And it's also not built with concurrency in mind. It's got this global interpreter lock that synchronizes everything onto a single CPU. And this prevents Python from running on multiple cores. And so you can think of Python more as a glue language than a high-performance one. Yes? So that's a good question. They have, so there's cooperative threading that you can implement. It depends on the thread package, where the individual threads would have to explicitly yield. And then, so whether or not it's preemptive threading versus cooperative threading is the difference between those. But typically, I think the preemptive threading is not something that it would support. But I would have to look. I would have to look at the thread package that you're talking about specifically to see what they're doing. Yeah. And I should say that Python is being used to call into C code that is multi-threaded. So like, this is why it's the glue language. Like all the machine learning stuff, it's like, oh yeah, I'm TensorFlowing in Python. You know, of course it's high performance. But what's really happening is that the package that gets compiled is all C. And you can see this when you install something. You can see it compiling the C files. And then it's just giving you this Python to C interface to call into the C code. And then the C code manages the parallelism. So there is that. So you can, but to do the high performance operation within Python itself is typically not done.
You said the interpreter was limited to one processor?
Yes, you have a single interpreter, but it could spawn off jobs that have threads that are in a different, implemented differently, yes. Yeah. So it has extensive packages, conciseness, and a huge developer base. And it gets you this. I put this in here because I like this cartoon. It's like Python, and you're flying. And you're like, how did you do that? I just import anti-gravity, and then I can fly. And this is what programming in Python is like. It's like, I don't have to implement anything except an import statement, and I get all this stuff. And that's similar to what you'll be doing with your app. I'm not asking you to program like HTTP. You're not going to be programming the headers or anything like that. You're not going to even be programming the HTML renderer or any of those things. It's all there for you. You just have to leverage the right package. But it also gives you this. And this is really painful for not only Python, but it's also painful for Node. It's less painful for Node, but it's still painful. You have all of these issues with installing the right packages. Because your app is probably only going to work with the specific packages that you installed and that you tested with. And this is where containers come into play and where virtual environments come into play. You have to basically create an environment, package up the environment that you used to get your app running. And then that whole environment has to be packaged up in its entirety and shipped somewhere else for another person to get that thing to run appropriately. And so this is what they're talking about, because there are so many places that can go wrong when you're developing on these frameworks. So in this class, you'll be using the pip package manager and virtual environment tool to basically create your own internal Python environments. And that environment is what we're going to be able to run to test your code. So that if you have some wacky package that you're using, you'll just specify that as part of your environment, and then we'll be able to incorporate that and hopefully get it to run. Okay, so that's the programming language. The next thing I want to talk about is the framework that you're going to use. So, and this is at a high level again. So the framework is basically library support for building your application, and it's often tied to the programming language. The two things that it will often support is basic routing. So routing of any URLs to the actual code that will process that URL. A lot of these frameworks also give you an opinion on how your web application should be structured. And typically this opinion will revolve around something called the model view controller architecture, which is something I think you guys cover it in CS430. This was developed in the 1970s and then adopted everywhere. And it was first used in web applications in the Struts framework, which was the Java web application framework in the late 90s. So there are three parts of the MVC framework. The first is the model, and the model is just any of the code that encapsulates the storage of back-end application data. So this focuses on storing the application data and representing it in storage, and then getting it to and from storage. There's the view, which is the code for rendering the UI. So it's generating the HTML output that you would get from accessing data from the model. And then the controller. This is the code that connects the model and the view together. So it takes in the user requests to update the model. So if the user wants to change something in the backend model, the controller will process that. And then it will also provide the view the data from the model that it's seeking. So these are the three components of an MVC architecture. This is what you'll have for your next three homeworks. You'll be developing a toy MVC app, and you will be making it such that it's pluggable, where you can plug the model in. You can change the model and then have the view and the controller still stay the same, is the idea. And so what this separation gives you is a separation of concerns that allows this to happen. So if I decide to go from a SQL database to a NoSQL database, I can just change my model code and everything will still work. And that's what I want you to see as part of your application deployment. Because what you'll end up, if you want to go from a legacy database backended web application to a cloud native sort of serverless database backend version, if you have done this separation of concerns very well, the amount of code that you have to change is tiny. And this is what you're going to do. You're going to go from a legacy MVC pattern to one that uses a server that goes completely serverless between homeworks number 2 and homework number 4 is the idea. And I'll talk a little bit more about the homework in a bit. Okay, so I do have examples of this. Of the movement from a legacy version to a serverless version using a guestbook app. And so this is when you clone this repository, well actually that should be 430 source, sorry, that hasn't been changed yet. But you'll see multiple versions of applications with MVC patterns with different model backends. And you'll be developing that on your own. This is what it looks like. So you have a model that is your backend data. You have a controller that's basically the logic of your application, your business logic, and then a view that will basically take models and present the UI or talk to the controller to change the model. Okay, there is another pattern that's also implemented in that repository, and it's called the model view presenter pattern. So the MVP pattern, rather than having a monolithic controller, the MVP pattern splits out the control into specific views. Every view is associated with a specific function. And rather than having a monolithic controller, you have views, you have a more vertical organization where you have a view and the view interface that talks to a presenter, and this thing, the only thing it does is the one function that the view is trying to support, and then that talks back to the back-end model. And so for every function that you implement, you would have a separate view and a separate presenter. So you wouldn't have a single monolithic controller, you would have a bunch of tiny presenters along with the views that they support. So this is another way of organizing an application. So it's function-based decomposition. This is much better for unit testing. Like if I have a development team that's just working on one of these columns, then they can make changes to the files without having conflicts into a single controller that might be monolithically handling all of the controller code. Okay. So people have been talking about getting rid of the controller altogether. This is the state action model that someone proposed. And the idea is similar to the MVP model, where you have some kind of state that is rendered, and then you have actions to change the model and to update the state. And so you don't have a controller anymore. You pretty much just have states, actions, and models, and then a view on top of that. And so actions are sort of like what the presenter was doing, was just doing a single function is the idea. So that style of decomposition is something that's being proposed. And you'll see some of these modern frameworks, web frameworks, are doing more of this style of operation. Okay. The third part is your template system. So the web app is using one language, which is typically JavaScript, Python, Java, or Go, to produce another language, which is HTML. And initially, when we first developed this, it was the programming language that was generating one string, and that one string was your HTML, right? And this was done with Java servlets. That got really burdensome, right? For you to write a program that generates all of the HTML in your program. And so in order to more efficiently generate the HTML, they started adding these tree building libraries. So on the server, you construct the DOM, the document object model. This is basically what you want the client to render. And you would construct that on the server using these tree building libraries. And when you have completely generated the DOM that you want the client to see, then you export that into the HTML string. And that was a little less repetitive than manual than generating the whole string monolithically. But it's still, you're having to redo this DOM every time you get visited by the client. You're going to have to do this tree building operation. And so what we have moved towards is a templating system. So you have a template language that specifies the base HTML page, and then you have like placeholders in the templates to generate the actual dynamic data that your web application is going to produce. And then you just fill it in. So that is what the template engine that is basically going to do, take the web application data and then take the template and generate the HTML. This is a template engine. So some examples of this are Java server pages. This was the very first one. Jinja 2, which is the template system that we'll be using for our projects here. And then if you've taken the full stack course, I think they use Mustache as one of their templating systems. And so these things can be used regardless of the language. Like you could be using Python with Jinja 2. I believe JavaScript, you could use the Jinja 2 templating system as well. So these things are separate. And so with these template systems, you're basically taking the view, which is in the template, and you're separating it from the logic, which is the web application that's giving you the data. So almost immediately, you have the view and the controller separated. And then for your project, I just want you to separate the model from the controller. And then you have a nice modular application. Okay, so here's I'm going to just walk you through what Jinja 2 is going to look like. I'll go through another Jinja 2 example next class. But it's got extensible HTML. It looks like HTML, except these double curly braces are going to specify Jinja 2 directives. So curly braces with an argument, this corresponds to an argument that's passed to the Jinja 2 template from the program, from the web application. So if I pass to this Jinja template that arg is equal to a certain value, when this shows up in the Jinja template, it's going to substitute value in for that argument. Okay? It's got curly braces % for control flow. So if I need an if, a for, or any other kind of block, I can say if the argument is there, I can say create me this HTML. Otherwise, end the if. So here's an example. This is an interface to one of the websites that we run for CyberPDX. There's a solve page that consists of challenges that have yet to be solved in a drop-down. So they have 24 challenges to solve. If they correctly submit one, it just highlights the challenge in green. And then this drop-down will only list the ones that they have yet to solve. And so the way this is done with the web programming language in Jinja, here is the Python code that collects all of the information that the Jinja template would need to do a conditional rendering of that page that you saw earlier. So it says, what are the ones that have been solved? What are the ones that haven't been solved? And then I'm going to pass to the Jinja template. So this is the render template. I'm going to pass to the template, and you can't see this. It's called solve.html. That is the name of my Jinja template. And I'm going to pass this template these two lists, the list of solved and the list of not solved keys. And then what's going to happen, this is going to get sent to the view via render template. And then you'll see within the template, I have a for loop that will operate on the not solved parts that have been passed, and then produce, this is the dropdown. For those that aren't solved, I will add a dropdown for that challenge. And so this is where you can programmatically give the data to the view. Okay, is this clear? This is the Jinja 2 template for that solve UI. Okay, and that gives you this. And then one other thing that you'll do in your homework is that you want to be able to handle form submissions. Oh wait, no. So in order to handle form submissions, you'll have a form here, and then you'll have a post method going to a URL. And then what you want to do for the post is that when the post is hit, you will want to use the parameters of challenge and guess to be submitted to your web application. And then this is what the controller logic will do to pull the form information. You'll pull from the request form the challenge that got selected, and then you'll pull from the guess dialog the guest name. So this is the way to pipe from the view. It pipes the actual data that you want to use in the controller to actually change the web app. So this is a pattern that you'll end up doing for your homework. So for your homework, you'll be presenting a form, you'll be getting a bunch of data, and then you'll be submitting it so that it can be stored on the back end. So I'm just showing you some of the piping that gets you from the template into the Python, and then I haven't shown you the back end yet. The back end stuff will be next week. Okay, so there are some issues with templating. Now you have 3 programming languages to learn. You have HTML, and probably more than that. You have HTML, you have CSS, you have JavaScript, and then you have whatever your web app is written in. So your web app is Python, so that's 4, and then you have the templating language, so that's Jinja, so that's 5, just to get a simple web app up. And so this is an issue. Another issue is that you have control operations everywhere. Right? Like you have an if, then, and a for loop inside of your Jinja template written in Jinja, but then you also have control flow in your Python app. So when you have multiple control happening in multiple places, this is where things get really confusing. And so this is a huge drawback for templating, is that now you can have code just about everywhere, and it's hard to reason about. Where should the conditional rendering of content actually go? Do you want it in the template, or do you want it all in the controller? And this motivates templating via domain-specific languages, where the DSL is built into the programming language itself. So you will see stuff like JSX, where you're basically building the template from within your JavaScript program. And these are systems that do this in JavaScript, where they're trying to take away the complexity of having a separate templating system. is the idea. Okay. So here is a survey of all the popular languages, their frameworks, and some of the templating systems that they will use. What we're going to do in this class, we're going to use Python with Flask and then Jinja 2 for our examples. But at least this gives you a sort of a framework to think about these things as you're selecting things for yourself. Okay, so I am going to take a 5-minute break and then finish off talking about modern rendering approaches. Okay, the next thing I'm going to talk about are modern rendering approaches, and I don't expect any of you to deploy any of this stuff in your web application, but I'm just giving you the roadmap because I think you will end up coming across this as you start developing web apps. If you are interested in being a full-stack web developer, this is the kind of stuff that you'll run into. So I'm going to give you a little bit of the history of this to show you where it's been, and that will help you realize where it might be going. When we build our web application, there are 2 rendering steps. We have the web application pulling in the data from the model and then rendering that into HTML or CSS for the web browser, shipping that over to the web browser, and the web browser renders the HTML and CSS to make a UI for the user. And initially, all of this stuff was running on the server. And basically, for this class, that'll be your app, this old school web app, because that's all we have time for. So this is your app. You render all that stuff, you take the model, you render the HTML, and then you ship the HTML and CSS over to the user, and the browser will render that thing for the user. Okay, this is what it looks like, and I pulled these figures from Isomorphic Go. So I wanted all the figures that you'll see here are from this book. So here's an example of what you're going to do. Your web app here. So that Python script is here. This is Jinja. This is the router, which is actually built into the script. All of that is sitting here on the web server, and then the user with the browser just asks for it with HTTP, and you get the response. So this is old school web app. It's all fine and good. But one of the issues here is that you have this repetitive server rendering. And this is especially painful if you have dynamic-ish content. Stuff that changes maybe once, and then from then on is the same thing over and over again. So for example, you have a news site, and every morning you push new articles up there, and then after that it's all static. Like, you don't make any changes to that site. But if you're sitting there running an MVC controller on the back end, anytime anyone asks for a URL, you're invoking the thing to reconstruct the DOM every single request. That seems pretty wasteful. That's an issue. So if you have a WordPress blog, it's only updated once a day. You're executing that whole logic and hitting the backend database to generate the same HTML over and over again. That's what you want to avoid. One of the things that has been pushed out is pre-rendered pages. So this is an approach for handling this dynamic content that doesn't really change. So the idea here is that the server is going to pre-render all of these dynamic pages into static HTML, and then from last class, you could take that static HTML and you can distribute it in your CDN. And so it might look like it's going to a back-end web application server, but it's actually being served statically from a web server that's just running nearby. So this is an approach that people are using to speed up their sites. Okay? The other advantage of this is that it can be returned to search engines. So search engines are basically trying to scan for all the content on the internet. If this thing is there, it can easily just pull it in and then crawl it to do the indexing. It's also more secure. You can see from the web security class, if you have an insecure scripting language running your web application and it's got a vulnerability, then people can actually get in there to compromise not only your web server, but your backend database. If you're pre-rendering this thing and shipping it out as static HTML, that's all they get, static HTML. They're not able to actually execute code or cause code to be executed on your backend. Okay, so this is now supported in most frameworks, and this is the reason why you would have pre-rendered pages. Another issue with this is interactivity. When a user navigates your site, it's going to hit the web application running on your web server over and over again. So this gives you really poor interactivity. You get a page reload every time you click on something. And so this motivates a push towards client-side rendering. Can I do more of these operations and handle them straight on the client? The first step in client-side rendering was to deliver an initial page to the client and then allow the client to just request asynchronously updates to particular parts of that page. So it would have a static DOM, and then within the DOM there might be a piece of data that might need to get updated. It would make an asynchronous request to try and update that piece of data, and then it would update it in place without refreshing the whole page. So this is called AJAX, asynchronous JavaScript. And this is what it looks like. The top thing is you request the initial page over HTTP. You get the entire page back with all the embedded assets. And then as you're navigating the page has some JavaScript that will asynchronously go back and then update parts of your page based on new data that you would get. Okay? So this is one step towards more client-side rendering of this page. So this eventually leads to more, oh gosh, I have a typo there, more operations that are being placed into the browser. We have all of these frameworks, jQuery, Bootstrap, Meteor, that are trying to do more of the operations on the client. And so you'll get the client-side operations that are much more responsive. You can just have the portions that have been changed, that downloaded, and then you get much fewer connections to the back-end server. Okay, so then one might ask is, can one render and ship the entire application and then just push it to the client? And the answer is yes. This is what a single-page application is. Ship all of the routes, ship the entire application and all of the routes that it supports in a single package. So the controller, the view, the controller and the view and the page rendering is all done on the client. So it just completely rips the controller and the view out of the backend, the MVC architecture that we had before. So typically this is a single HTML file, a CSS bundle, and a bunch of JavaScript. And then most of your modern web applications are doing this, like Gmail, Google Maps, Facebook, and GitHub. And then the backend will ship you the application, but then all the backend does is supply an API for the model. And then all you're doing is dialing home to the backend model of any of these services. And this is why you would want to run Go on that backend model, because everybody's hitting their mail. And so whatever is processing all those API requests better be fast and it better be multi-threaded. That's why you would have Go, because of this style of web application that we have today. And so now you end up having a web app that has a view that basically directly interacts with the model via a backend API. So this is a different way of architecting your web app. For Angular, they call this model view whatever, MVW. So just get rid of the controller. There's no controller there. Vue has this view model, and view that's more similar to MVP. Again, you don't need a monolithic controller anymore. Okay, so advantages. Essential static content is delivered ahead of time. There's no need to refresh. So as soon as you start navigating that app, as it's been loaded, it's really fast. I was really happy. I have a fantasy football team, and like when my fantasy football news site went to a single-page app, it was like, great, I can get all this news without having to go back to the web server to refresh the data. So simple things in life, I guess. So yeah, your network calls are minimized because you try and get that ahead of time, right? And it's super responsive. It's like you don't even have to make a network request to get new pages out of your app. Okay, the disadvantages is you have an initial load time for heavy client frameworks. So yeah, when you hit the site and it sits there and it loads, you're like, yeah, that has to be, you want that thing to be as short as possible, basically. This is what it looks like. So in this case, I make the initial request over HTTP, and I get the whole package. It gives me the logic, the template renderer, the router, because I need to be able to route all of this stuff. It's going to give me a huge payload. It's going to, and then it's going to give me the view to update. the controller logic, and all of that. So after I do this download, I'll get this. And then the back end doesn't really need the template rendering. It just has this web app, and the web app is just producing this, it's just delivering the web, the application itself. But it also has to implement this REST API, or whatever API it's going to use to get all the model data to and from the single page app. So for example, if this is Gmail running here, then this REST API has to be able to get all your messages. And then when you send stuff, it has to accept your messages. And then pretty much you don't talk to Google that much after you download that app. Okay. Are there any questions about this? All right. So drawbacks. This is not good for search engine optimization. Web scrapers don't like doing full-scale JavaScript. And then running an actual application, they like crawling links and pages. And if your page is one enormous HTML file, they don't like that. And they won't be able to render the individual pages on your, they typically won't follow the links there. So that's a problem. The other problem is that this is huge complexity at the client. And this is why full stack development needs to be more than just one course. And I think Katerina is going to try and split it into multiple ones. Because this kind of complexity you can't learn in just 10 weeks. And this is where all of the frameworks are being developed to try and manage this complexity that's being placed onto basically your web browser is doing all of this. So that's, if you like this kind of stuff, this is where 465, 565 would be your cup of tea. I actually sat in on this twice, and it still like, it didn't sink in very well. So one of the drawbacks here was, can you render a version of this single page application that the search engines can index that is identical to what a client actually sees? So this leads to something called isomorphic web pages, and isomorphic means it has the same shape. So what isomorphic web pages is a way of rendering in an identical page on both the client and the server, and then allowing the server to issue those pages in substitution for the client. So maybe if a search engine is looking for what a client page would look like, the server can just say, oh, here's the HTML, index that. But if I have a client and the client wants the single page application version, it'll download the whole package, but it'll look the same. Like the rendering on the client and the server will look the same. So that's what the isomorphic part is. The idea is you serve this initial, and then the nice thing about an isomorphic web page is that what you could do is you could serve the original landing page as a pre-rendered isomorphic page while you're shipping the single page application that's going to take a long time to load. And then it's going to give you the identical page. You can just switch over when you have the whole single page application loaded. So that's, in fact, that's what this is. So yeah, the model would be, as you're shipping the single page application in the background, you can seamlessly switch over to that after you download, but in the meantime, you would serve this initial page that's got the exact pre-rendered version. So that's the magic of isomorphic web pages. Okay, so the benefits of this: fast initial load, good with search engine optimization, and then eventual responsiveness. So once the single page application arrives, then you get the responsiveness you would have gotten before. Okay, so here are some examples: Angular Universal, and then there's an article on Airbnb that talks about their framework for web apps that's using isomorphism for that. Because they, in particular, have multiple clients that they want the same thing to be rendered with. Okay. The key to this is that now there's rendering on both sides. This picture's a little different. Like before, the server wasn't doing any rendering, but here both the client and the server are rendering, and then the server is dishing pages for search engines that look exactly like what the client would have seen if it rendered it locally. So you will download the whole package, you will do the rendering, and then as before, you would be doing asynchronous JavaScript to update the client with the server if you needed to. So these are model requests to the API is basically what these things are, as we mentioned earlier. Okay. Whoops, animation is skewed. So those are isomorphic web pages. You would eventually like isomorphic web applications. So one of the things that that you would like to do is build collaborative multi-user applications. So some examples include this. This is Slack. It's like when we're all on the Slack channel, it's like we're sharing a single application, right? Like when somebody posts an image on the channel, everybody gets it that's on it. So this kind of collaborative application is really hard to do with this style of web interaction, where you're just doing asynchronous JavaScript in order to update an application that might have many updates per second. There's all sorts of people. And so, for example, this is another example, a shared Google Doc, where you have 3 or 4 people modifying a document at the same time. To do all of this with these single asynchronous HTML or HTTP requests, that can become cumbersome. So we are moving towards a sort of an environment where you have a shared real-time database that needs to be shared as part of your web app. And then you would like isomorphic rendering with minimal overhead that works on both the server and all of the clients that are participating in this shared view. So that is where an isomorphic web application comes in. And so if you are using the same old REST and JSON way of doing things, this breaks down very quickly when you have a lot of collaborators. And so what things are moving towards are real-time clients where the database operation is handled directly. Everybody runs the model in this case. So before, only the backend is running the model. So the model's not pictured here, but only the backend is really running the model. So the idea here, when you have a collaborative application, is to run the model everywhere. So everybody's running the model and the view. And then what's happening is that you're just synchronizing the model between all 3 copies of it. And that synchronization is done to the authoritative server, any of the clients, and then there's a sync protocol that could be run over something like a WebSocket rather than HTTP that will actually do the data syncing between the models. So this is another style of web application, and this is taken from, no, it's not taken from Meteor. This is taken from that book, but this is something that Meteor.js is talking about with database everywhere. And the reason why you would do database everywhere is if you have everyone needing fast access to the model, and then the synchronization protocol is going to handle any conflicts between people updating the same thing at the same time. Okay. Another issue with rendering pages is disconnected operation. So when you start shipping web apps as a single page app to a client, this is very close to what a native application on your phone will do, right? So you get all the interactivity of an app running on your phone, but whenever you do eventually need to update the model, that's when it goes over the network. So what you would like to do is make your single page app exactly like a native application, to have the look and feel of a native application entirely. And so in order to do this, in order to support a Google Doc looking and feeling like a Microsoft Word experience, you need to handle disconnection. And so to handle disconnection, this is what progressive web applications are doing. So a progressive web application seeks to do, for a single page application running on a phone, it seeks to, because you're already pushing all of the content locally and you're doing the navigation and the view updates locally, what it seeks to do is give you this interface that's very responsive, even if you're disconnected. So I didn't do any animation here. Even if the network is broken, you would still want to be able to navigate your web app. And the idea of progressive web applications is to make this seamless. And it's the progressive web application is hiding the fact that you're disconnected. And the way it's hiding it is through something called a service worker. And this service worker is sitting between your application and the web server. It's allowing you to do updates on the UI. And then it's taking those updates and it's sending them to this service worker, which is going to batch all the updates up. And then as soon as it gets the network again, it's going to send them all out. And then it's also going to receive any updates when it gets reconnected and then automatically update your UI. And that allows you to get this disconnected operation where you can actually edit your Google Doc when you have no network, when you're on an airplane, for example. So this is the idea behind progressive web apps. And I mentioned promises and closures before. This makes heavy use of JavaScript promises. And promises are a way of saying, hey, you know what, send off this operation and then give me a callback that says whether or not the operation succeeded or failed. And so if everything is done as a promise, your update to the backend, then when you get reconnected, you'll get all the code running that needs to run to update that thing on the response when you get reconnected. So that's the idea behind that. Okay. Other questions about this? Yeah.
How much could you write in a Google Doc on like a typical page? Like that sounds.
Yeah, I don't know. Well, I mean, enough for your computer to store, but then that will all get stored as changes to the service worker, and then when the service worker will eventually submit those all the way to the back end at the reconnection. Yeah.
When the service worker eventually submits all the data to the batch and receives data, is it data ordered?
It's ordered by, so it's ordered for that client based on what it got from the client. Yeah, so it has that order, and then it can submit those one at a time to the back end. Yeah. Okay. Yeah. So the server is binding sessions to a cookie and a user typically. So it would know which document, for example, and which user those changes are meant for. Oh no, this is meant to be the same server. So there is one authoritative server for handling Google Docs that you're communicating with, and if you're disconnected from that, and then when you reconnect, you'll be going to back to the same server to issue your updates. And then your definitive copy is stored here on Google. It will just update all those changes as soon as you reconnect. Yeah. Okay, finally, there's too many frameworks. This is what most people have come across. It's like, because the complexity that's being tackled, you have developers reinventing wheels left and right. So a lot of the things that are in React, that are in Angular, that are in Vue, they are different ways of solving similar problems. And the way they solve it is typically incompatible. And so the last thing I want to talk about is a component model. So the W3C has seen all of this wasted work. And so what they're looking for is a component model where you can have standard web components that people, UI developers can just, drag and drop into their web app so that you're not having to learn a new framework every quarter, every year. And so that's the next thing that is part of web development. Okay. And so with that, I want to talk briefly about homework 2, if I have time. Yes, I have 10 minutes. So this is a little bit ahead of time. It's not due until a couple weeks, but I want to give you a preview of it. Whoops. Especially if you have mostly finished the labs and you want to take a look at this. This is your first programming assignment, homework 2. And the preview is that your 4 homeworks, let me see. No, 3 homework. The next 3 homeworks, this didn't get changed either. All right. I took away a homework from this course. I'm sure. I hope you all don't mind. So what you're doing in the next, that's homework 2 through 4. So the next 3 homeworks, you're going to first develop this simple MVC application using Python Flask. And what you'll be building is a scalable bubble tea website where you allow users to submit bubble tea places that are their favorite places to go to for bubble tea. And you'll be keeping track of all of the different bubble tea locations that have been submitted. And then when someone goes and visits your site again, it sees all of those entries in your site. I want you to at least we'll talk about create, read, update, and delete, but this is the CRUD sort of model. You're basically going to support reading and creating bubble tea locations on your website, and you can add delete as a stretch goal for this homework number 2. You're going to have an MVC developed back end, and this can be derived from the code in the repository. So what I've done is I've given you an MVC pattern that implements a guest book. And you're going to take that guest book application and you're going to change it to implement this bubble tea application. And you can just derive it right from the source code that I give you. Or if you think that that source code is awful, which it may well be, you can re-implement your own. I don't mind that. I won't take it personally. In fact, I'll probably ask you if I could borrow your code for the next time I offer this class, for those of you who do web development more than me. The next homework after this, 1 week later, I'm going to ask you to I'm going to cover containers by then, but you'll be containerizing that app and then deploying it on a compute engine instance. And then what I want you to do, this is full-on legacy framework kind of stuff. I want you to go full serverless with this app. And because you have developed an MVC pattern, you will be able to take the model and go from a model that's SQLite 3 and be able to just change it so that it now goes to this serverless cloud data store backend. Likewise, you are going to deploy this on a server. You're going to set up a compute engine instance and start a server. What we're going to cover is a way of going full serverless on that, where you're just deploying this on App Engine. And then when you go from here to here, you have something that if your app was really popular and got millions of hits a day, you would be able to support all of those requests in App Engine with Cloud Data Store without any other engineering resources. You would just be able to have that run. And this is where I want you to go at the end of the course. So you can see legacy, and then you can see where everyone wants to go. Well, most people want to go, I would say, is over here. Okay, so are there any questions about this? Yes.
Yeah, I'm thinking around the due date. What's the due date?
It's November 2nd or 3rd. So one of the things you'll see that there are labs also in this part, but the labs are lighter for this section just because I'm having you do this homework. There will be a couple of labs. I would really recommend you do the labs because the labs will make your homework easier, and that's what these labs are for. The labs are for, hey, I know, run a Python Flask app is one of the labs. Well, that's what you'll be doing for your homework, so hopefully you can do that lab before you're starting your homework. Yes?
Is there a 5 or
No, it should be a 4. I fixed this, but Google Drive has always given me the older version. So yeah, that should be a 4. So yeah, full-on server-based implementation, number 2, and then container version, and then a serverless version, number 4, yeah. Yeah, okay, so I didn't want to go through the actual homework 2 yet, but you can pull through here. Some of this stuff I need to explain. But you're more than welcome to take a peek, for those of you who are itching to do the programming parts of it, you can take a look. I will eventually describe what all of this means when I get to it. But I need to cover the Python Flask and then SQL in order for you to really get going on this. And by the end of next week, you should definitely have enough to tackle the homework. Okay, so I'll stop here.